So I've already solved number 15 in a previous video with reductio ad absurdum. However, this could also be done with conditional proof, and hopefully this is a good teaching moment because you can often do proofs different ways depending on which strategy. So hopefully this will help you with practicing your conditional proof. When we did reductio ad absurdum to solve this, it took 14 lines. And I think if we use conditional proof, it actually takes less lines. So it's quicker and more efficient. So let's try to do that. If we're going to do conditional proof, well, the reason we're going to do conditional proof is because, remember one of the tips for constructing proofs? Think about what's equivalent by the equivalence rules to the conclusion or the premises. Hopefully, this conclusion jumps out at you as being equivalent to something else. By material implication, our conclusion is actually going to be equivalent to if A, then B, which is a conditional. Now, in order to get this conditional, let's try to use conditional proof. Conditional proof is actually, most of the time, a really good strategy for deriving a conditional statement. And remember, the idea for conditional proof is in order to prove if A, then B, you can assume the left side of the conditional. You don't know if A is true, but you're just going to assume it. And if from that, plus the premises, you can derive B, that means you've shown that if A, then B, which is exactly what you're trying to prove. So you're trying to prove a conditional. That's a good idea to use conditional proof. What do you assume? Assume the thing on the left side, because you don't know if A is true, but you're just going to assume it for the sake of argument. So if A, and if you can prove if A, then B follows, that means you can write the conditional. If A, then B. So let's go ahead and try to do that. So we're going to try to prove this conditional and then use material implication to transform it to this, which is equivalent. So if we're going to try to prove this conditional, that means we should assume the thing on the left side of the arrow, which is A. So we'll assume A for conditional proof. And now our goal is to get B. Once we get B, we can close our box and we can write this conditional. So we have A. We need to get B, which means we need to get maybe F. Well, what can we do? We have A. There's only one place A occurs, and it's in this not A, inside this conditional. Hopefully it jumps out at you with 2 and 5 that these are good ingredients for modus tollens. But of course, for modus tollens, you need the negation of the right side of the arrow. The right side of the arrow is not A, so what's the negation of the right side of the arrow? It's not A. So that means 2 negation signs. And of course, since we have A, we could easily get that by double negation. So let's do that. Not A. And now we have the negation of the right side of the arrow. So with 2 and 6 modus tollens, that gives us the negation of the left side of the arrow, not Q. All right. What else can we do? Well, we got not Q. Look up here. We have a conditional if not Q, then L or F. That'll probably be handy. So let's use that. 1 and 7 and that's modus ponens, and it's going to give us the right side of the arrow, which is going to be if L, then F. All right, we're still trying to get B. Remember, we wanted to get F, so we could do modus ponens to get B. Well, we're getting pretty close. We just got if L, then F, and up here, I look up and I see we have L. So 4 and 8 together are very nice. 8 and 4 modus ponens is going to give us F. Is what we wanted. And then with 3, if F then B, we also have F. So by modus ponens, that's going to give us B. And that's exactly what we mapped out for our strategy. We wanted to assume A and try to get B so that we would be able to show that if A, then B, which is what this says. So now we can close our box, which was all based on the assumption if A, and by conditional proof, 5 through 10 CP, we've shown that if we assume A, we get then B, which we're not quite to our conclusion yet. Remember, we said if we could get this conditional, then because there's the rule material implication, MI, when we apply that to 11, it gives us not A or B. And now we have our conclusion. Awesome. Notice we only took 12 lines. For our reductio, when we used reductio to construct this proof, it took 14. So there's different ways to solve, to construct each proof. Usually for me, when I see a disjunction, I think the much easier way is to try to do a conditional proof rather than a reductio. But it's fine if you do a reductio. It doesn't matter. It's hardly ever a bad idea to use reductio, unless, of course, you're assuming something that's not going to be helpful. But if you're assuming the opposite of something that you want to get, it's hardly ever a bad idea. It might take you longer to construct the proof with reductio, but it's probably not going to lead you astray, as long as you pick the right thing to assume. All right? Awesome.